Welcome to this walkthrough of the AWS architecture diagram for a mobile web application. Since we're in the cloud advising section of this course, I want you to think about this diagram as information that you will present to the stakeholders of a mobile web application company who currently have their IT assets 100% on-premise and are looking to migrate to the cloud for all of the benefits that we have listed thus far. This diagram will show the different AWS services that are used to build a scalable and cost-effective serverless architecture for a mobile web application. Now again, just think about the diagram as a visual representation of how different AWS services are used to create a serverless architecture for a mobile web app. By following this architecture, developers can build mobile web applications that are both reliable and cost-effective. Now, I'm going to be honest, the diagram is a little complex for someone who isn't used to the names and terminology used in the software architecture environment. We're going to briefly focus on four main components, each representing a different function of the web application: the web client, the API gateway, the Lambda functions, and the DynamoDB database. The web client is the user-facing part of the application where users interact with the web application's interface. This is where you get the pretty colors, cool fonts, input boxes, drop-down menus, etc. The API gateway is responsible for managing and securing the APIs that the web client uses to interact with the application's backend services. And the backend services are just a part that the users cannot see and are responsible for processing and storage functions. Now, an API is a way for different software applications to communicate with one another. Think of it like this. Think of a waiter at a restaurant. The waiter takes your order, delivers it to the kitchen. The kitchen prepares your food, and the waiter brings it back to the table. In the same way, the API is the waiter, and it takes requests from one application and delivers it to another. The receiving application then processes the request and sends back the response, which the API delivers back to the original application. The Lambda functions are serverless compute resources that execute the business logic of the application. Serverless compute resources are like the little helpers that do important tasks in the application. They work without us needing to manage a server or infrastructure. Instead, we use resources provided by a cloud service provider. When something happens, like a user makes a request or there's a change in data, the serverless compute resources get activated and perform the task and goes back to sleep when it's no longer needed. And lastly, the DynamoDB database, it simply provides us persistent storage for the application's data. Amazon DynamoDB is used for NoSQL data storage, providing a scalable and highly available way to store and retrieve data. Now, DynamoDB is designed to handle large amounts of data with low latency, making it well suited for a mobile app. So DynamoDB also supports a flexible data model. This allows for developers to store and retrieve data in a way that makes sense for their application. All right, as we move on a little bit, we'll see that the diagram also shows the different AWS services that are used to build the mobile web app. Amazon S3 is used to host static web content, including HTML files, CSS, and JavaScript files, which are served to the user's browser. Now, if we go to the beginning, you'll see the Amazon Cognito block. Amazon Cognito is used for user authentication and identity management. Cognito provides a scalable way to manage users' identities, including authentication, authorization, and user profiles. Cognito can also integrate with other AWS services such as the API gateway that we see there, and Lambda to provide secure access to specific resources. The AWS architecture diagram also shows how the mobile web app can be deployed in scalable and highly available manner using services such as elastic load balancing and auto scaling. Now, these services are useful as they can be used to distribute traffic and automatically scale resources up or down based on demand. Now, the last thing I would like to point out is the VPC section and how the two availability zones are configured. The VPC, or the virtual private cloud, is a virtual network that's isolated from other networks. In this diagram, the VPC is used to provide a secure and isolated environment for some of the functions in the mobile web app system. The availability zones are distinct locations within AWS regions that are engineered to be isolated from failures in other availability zones. In this diagram, the mobile web application is deployed across two availability zones, A and B, to ensure the high availability and fault tolerance, and that's indicated by the mirrored functions within the two. Now, if you continue to look, you'll see the private subnets. A subnet is a range of IP addresses in a VPC. Private subnets are subnets that are not directly accessible from the internet. So you'll notice how the Amazon ECS and the AWS Fargate, which is a serverless compute engine for containers that allow developers to run Docker containers without needing to manage the underlying infrastructure. And you can see they're deployed within subnets and they provide an additional layer of security. Now, I know there might have been a lot of things, but let's just wrap it up. In this walkthrough, we focus on the AWS architecture diagram for the mobile web application, highlighting the different AWS services that are used to create scalable and cost-effective serverless architecture. The diagram is intended for stakeholders of a mobile web app company who are considering migrating their on-premise IT assets to the cloud. Initially, we talked about 4 main components, and they were explained as the web client, the API gateway, Lambda functions, and DynamoDB databases. We continue to talk about the Amazon S3, which is used to host the static web content, and the Amazon Cognito, which is used for authentication and identity management. And lastly, we focus on the VPC, availability zones, and private subnets, which are also explained in detail. Elastic load balancing and auto-scaling are used for scalability and fault tolerances, and private subnets are also used for additional layer of security. Okay, I hope that wasn't too much of an overload for you, and I will see you in the next lesson.